Howdy folks, Brian Cusco here, Triple B. This week, we are bringing you back to the long-lost Herpeton sessions, and we're starting with one of my favorite speakers, Scott Stahl. Scott is going to be discussing reptile theriogenology. What the hell is theriogenology? Well, a theriogenologist is a veterinarian with advanced training in animal reproduction. Scott included some really good imagery and video footage of the insides of reptiles in this talk. If you are interested in breeding reptiles, especially about how to tell a male from a female and many different species, this is going to be a real treat for you. You're watching Triple B TV.
So I'm very excited to discuss one of my, within my veterinary field, my passion, actually it came from you guys, it's a passion for herpetoculture. And so if I take that passion and I relate it to veterinary medicine, how can I figure out a better way to help us all to do a better job with our captive breeding? And so this is a topic that's near and dear to me. And so that reproductive theriogenology is kind of that's the veterinary buzzword that's used for a focus on the veterinary side of reproductive medicine. And so reptile theriogenology is what we're going to talk about. We talked a little bit about some of these things yesterday when we were doing our Q&A. These are some of the things I'm proud of. I bred the black tree monitor a number of years back. It was one of my babies hatching out. So again, like you guys, I get the same high or whatever from seeing these animals hatch out. So we've made a lot of advances that as we've been talking about over the week, and of course we've made some inroads into success with captive reproduction. And one of the reasons that we're doing it, we're doing such a better job with these animals now that they're healthier and they're willing to breed and they're ready to breed, because we're finally getting closer to achieving a better husbandry situation for them. And of course we've learned even more over the last couple of days about that. And then, of course, I think we've all learned, again, many people in this group are the reason that we've made success here in these areas here, including the perinatology and egg incubation as well. So these are all very exciting times from that point of view. Again, herp medicine and surgery, we talked about this yesterday, how I think we've made a lot of advances there as well. And again, applying those and applying veterinary medicine to what you guys are doing, I hope you guys can find room for that. I think that we need to try to work together. Again, I'm passionate about these animals. I know you are, and so I'd like to see them get the very best of care, including medical care as needed. And then my theory here is that I do feel there's the production management side is something that we as veterinarians should be offering you guys. How can we help you guys do a better job with your breeding colony? Not necessarily with your pet bearded dragon, but with your colony of bearded dragons or leopard geckos or whatever, cresties or whatever it is you're working with. And certainly through disease management and helping with quarantine, et cetera, but also through looking at production. What are the production numbers? How many babies are we producing each year? And how can we improve upon that? What things can we do to get better fecundity from our females, et cetera? So those are things that I think you'll find there's a chapter in this book, a theriogenology chapter, that was sort of the thesis of my life. It's about a 50-page chapter. It took me about a year to write, and there's a lot of this information I'm sharing with you today. If you can get a deep read in there, I think you'll enjoy it and find it useful. And then Doug Mader here, this guy in the center. This is Steve Divers, my colleague, myself, and Doug in the center. And we felt it was the right thing to do to dedicate this book to Doug, because Dr. Mader was the one that basically wrote and edited the first two editions, and so he didn't want anything to do with this book this time around. He said he was done, and so we said, what should we do? Oh, we better do the right thing. So we put his name right at the top, and as we already know, everybody's already calling it Mader 3, so it's like Steve and I didn't do a thing over the last 3 years. Doug gets all the glory, but oh, whatever, it is what it is. So anyway, but we're honored that we got to honor him in this way. And then remember ARAV, the Association of Reptile and Amphibian Veterinarians. We talked about that yesterday. That was a good place to consider donating research money and also to find veterinarians that also have the same interest that you guys do. So arav.org. All right, let's move on. Let's get into the thick of it here a little bit. And I can't help but thank these guys one more time. So again, with all these, the things that have been mentioned to us here, we've got this pressure to do better, to do a better job, to figure out a way to help not only with what we're working with in captivity, but to be stewards for what's happening in the real world. And so it's very important that we do all this. And I thank these guys for inviting me and allowing me to be involved as well. All right, here we go. So quick, we're going to start with some basic anatomy. All right, try to work you guys through this real quick, but just to kind of give you a review. Again, most of you are experts on this, but we'll start out with our female snakes. Remember, we have ovaries that are paired and elongated. So these are your ovaries here. Unfortunately, this is not a surgical specimen. This is a necropsy animal here. All right, so these are those elongated ovarian follicles, and these have some development on them. And these are what we call follicular phase. So there's some activity here on these follicles in this particular state. It looks like maybe a carpet python. And then this is a surgical case here. And what I want to show you is how thin these oviducts are. This is why trying to manipulate them outside the animal by pressing and pulling and tugging is probably going to result in tear and damage to these oviducts. So just remember how thinly walled they are. And then a very nice paper that was written by Helen McCracken out of Australia. What she basically did is she looked at the different organs of snakes and sort of mapped out what the percentage of those organs are within their snout to vent length of the snake. And so you can see the red boxes here. This is the gonads, if you will, of the female, the ovaries and their location. The head's this way, the tail's this way. So you can see that, again, most of the reproductive tract is in that lower 1/3 of the body. So those ovaries are going to be lower and located in that part of the body. What about male snakes? Testes are paired mid-dorsal coelom, so they're a little more craniad, found between 65 to 82%. Again, the green squares here, and these are families, by the way, Boidae, Elapidae, Crodalids. These are all sort of listed across here, as you can see. They're all fairly close. There really aren't any snakes that have their gonads in any more of an unusual spot than any others. One of the things that's very interesting is there's something called the renal sexual segment, and it's a squamate thing. It's in snakes and lizards primarily, and what basically it is it's the part of the kidney that becomes active during the reproductive cycle, and it basically produces what we think of as consistent with like a seminal fluid that basically is part of the ejaculate, if you will. And so when it's been studied and looked at, that's sort of what it looks like is happening there. But one of the things that's quite interesting is this is a more normal looking kidney right here. It's a very dark looking structure like a stack of coins. This is the adrenal gland, that little pink structure that you see. This is a kidney in a snake, a male snake that is actually during the breeding season. So this, you see how pale looking this kidney looks compared to this one. So if you weren't aware of this renal sexual segment, you might determine that that's pathology and think that kidney is not healthy. But it's actually on histopathology, this kidney would be quite healthy. It just would be quite active with that sexual segment. All right, so important things that are a little bit different. And then I think we all know about the paired hemipenes. Remember, there's no urethra in this structure, so that it's not used as a way to pass urine out of the animal. So again, the fact that we have two, if we lose one, then we obviously it doesn't affect us. We can still potentially breed, et cetera. All right, so what about lizards? Again, our ovaries are paired sort of mid-dorsal coelom, again, near the adrenal glands. Adrenal gland tissue is right here. You can kind of see a little pinker looking structure. This is a green iguana. This is probably one of the most common surgeries that we do. It's a reproductive surgery where we remove these enlarged follicles on these ovaries. These are static ovarian ovaries that basically have gotten to this size and then not moved on. And so a lot of times we'll go in and just remove the ovaries from these guys and they can become better pets. This is a more immature ovary with small follicles developing. This is the lovely vasculature, the vena cava that kind of runs very close to the ovary. So when you're doing surgery, it's quite delicate there. And then here's the oviduct here. Again, notice how thin wall the oviduct is. So any type of squeezing, pushing, and pulling on these guys is very likely to result in damage and tearing of the oviduct, et cetera. And then this just shows a little bit of the blood supply and the layout with the female ovary and oviducts. Male lizards, very similar to what we talked about with snakes. They have that sexual segment, and you can sort of see, so here's the testicles here, the vas is coming down here, and then look at these kidneys look very abnormal. Again, they should be more of a darker mahogany color, and they've got these areas of blanching white. Now some of that is probably post-mortem change, but again, when that sexual segment is active, those kidneys can look very different here as compared to a more normal looking, darker kidney here. Testicles, and then the vas deferens coming down here. Epididymis is hiding in here somewhere. And then, again, the hemipenes, and then your vascular supply there. Female chelonians, the ovaries are paired and near the kidneys when they're small. As they grow, though, you can see how, I mean, these ovaries become massive in these animals. And so they become more pedunculated, and they can hang down and away from a lot of the organs. So they initially start out when they're young near the kidney, but then as they grow with these maturing follicles. And a lot of chelonians will have follicles year-round, we find. They aren't necessarily as seasonal as the lizards and snakes tend to be. And then here's sort of a pro-section to show how much thicker the oviduct is in the chelonian species. And then here's a sea turtle here. It just shows a little bit. These are some more immature ovaries here. And the kidneys are kind of in this area right here. What about male chelonians? Again, of course, we know it's this phallus thing. Again, no urethra. So when this guy comes out, it's quite dramatic. And here's an Galapagos tortoise with a well-endowed guy here. And then some kind of a slider here with, this always scares the clients when they come in, when they said it's like prolapsed its intestinal tract, and you have to look them in the eye and tell them, no, that's actually its penis structure or whatever, and it's going to be okay. And then here's the anatomy. You can sort of see how high up the testis is here with the epididymis, and then the vas coming down, and then that the phallus or copitor organ kind of hides up in here, which is why, of course, the males have the longer tail, which we'll talk about sexual dimorphism here shortly. So that's a little bit of our male chelonian anatomy. So what we're going to talk about for the next few minutes is the challenge of sexing reptiles in general. We call it sex identification, and snakes are probably one of the easiest ones. And again, you guys being an advanced group, I don't have to talk a whole lot about this with you all. Thanks to Joe Laszlo, who's one of the guys that actually sort of developed this probing technique that was part of our club here for many years before we lost him. These are the techniques that we use most of the time for sexing the larger snakes. And again, I know you guys are familiar with that. There are a couple of species that we find that don't follow this. Those of you that work with short-tailed pythons know that it's not very accurate for them, or at least in my hands anyway. We have a hard time sexing them with probes. Males and females seem to probe almost exactly the same in our experience. But generally, hemipenal probing is quite effective for most snakes. There is some sexual, obviously some dimorphism changes that go on too. Again, with many boas and pythons, the females are larger than the males, etc. But these are some of those characteristics that we're all familiar with. And then there's this hemipenal popping technique that has become quite popular with juvenile snakes. We primarily use it in the young animals because there's not as much musculature to hold these hemipenes in place, and so with a little bit of digital pressure and some practice, you can get quite good at sexing young snakes with this digital popping. This is a male. These are ball pythons. This is a male where you typically get this little structure that will come out and literally extend up, and it should be flat on the top. That's one of the ways that we can try to identify. And people that do this routinely can get quite good at it. And then a female over here where we don't really see the clitoral structure come out, but you typically see these little scent gland openings that will kind of pop up, but not nearly as definitive as the male. Again, primarily juveniles, you want to use caution because you can certainly cause trauma to the spine of the snake if you're too aggressive with this. But this is a technique that's become quite popular. And in the right hands, I think it can be very safe. So snakes are pretty straightforward. Well, lizards, they're more of a challenge, right? And some species, of course, have lots of sexual dimorphism. And again, I know this group's quite familiar with all these things. So, of course, the green iguana we use as the classic example with the male with all these, the large dewlap and the jowls and the spines that are more dramatic than the female. And then the femoral pores are much more dramatic in the male as compared to the females. And then for a lot of our gecko species, we have the preanal spores. So in the leopard gecko here, you can see pretty dramatically those pretty active little glands there, and then not here in the female. The thing to remember, though, here, this is the important takeaway, is that these things aren't present in juveniles, okay? So most of these characteristics occur when testosterone or estrogens and progestins get into the system, and that's when changes occur. But it's not real helpful to us in young animals because they don't have those sex hormones blasting through their bodies. So that's why this is helpful maybe for mature animals, but not so much. And then again, there's a lot of species that don't show these types of characteristics. So that creates the challenge for us. A few more of them, obviously some species, with the Triosaurus, the jacksoni, the male with these lovely horns, and then the female down here. And then here's some crested geckos showing the dramatic hemipenal bulging for the males compared to the females, and of course, this female missing her tail. So there's been a number of different studies and projects, people looking at ways to try to figure out how we can sex a lot of these typically juvenile lizards is what we're trying to figure out how to do. And so there was a really nice study that came out of Australia by Phillips and his crew. Robert Johnson is also an author on that paper. And what they found, they always felt that males in the Teliqua group, Skincoides intermedia, that whole blue-tongued skink group, people generally felt that adult males would have a larger head and that the females have a longer trunk to the body. So what they did is, you can see the measurements here that I wrote here for you. So the heads were measured, and then SVL, snout to vent length, was measured, and then a trunk size. And they actually made and correlated a little percentage by making these little ratios here. And they found that when they used those ratios, it was pretty predictable that they could predict, based on these measurements, males versus females. So that was a really nice study that came out. So you can start measuring if you're working with Teliqua, you can start doing that, and that's one way you might be able to sex some of your animals. But again, we're talking about mature animals here again, right? So that's part of the issue. And then bearded dragons, of course, they're our most popular pet now, thanks to Bob Mayhew and Philippe de Vaugelet back in the 90s, bringing that original group in. So anyway, here we are. And so this is a website that I went to, and sure enough, it shows nice pictures of these adult males with the hemipenal swellings. This trick where you kind of lift the tail up while you leave the animal flat on the table. The female tends to be more hollowed out here because those hemipenal structures are not there. So that's a technique that can work. And then also this transillumination, this is also borrowed from the beardeddragon.org website. People use a powerful light source. Again, you need to use caution. You can cause thermal burns to these tissues, but in light-colored species, like a lot of the lighter-colored geckos, bearded dragons, things like that, you can actually transilluminate with light these areas, and the idea is that the male will have increased vascularity and structure and tissue as compared to the female. And I think that's pretty evident here in this male. You can sort of see the hemipenal structures as compared to the female here. So this is a pretty neat technique. Some people are able to do this even with the light source on their phone. And so with a lot of the smaller geckos. So that's a pretty cool technique that's been utilized as well. So for lizards, probing has not typically been something that's been very effective, although you'll talk to some people and they will say that they have good success doing it. And so it's not something that I've had great success with, although we continue to sometimes try on some of the species. One of the things that I will do sometimes is inverting the hemipenes with gentle pressure. With a lot of lizards, like the bearded dragons, where even as subadults you can't tell yet what sex they are. Well, my clients, that's one of the main reasons they've come to me, is they want to know whether it's a boy or a girl, So anyway, sometimes, if I'm lucky, I can pop the hemipenis on the male by surprising him, if you will. So I'll very gently manipulate him and then do similar to like you pop, the hemipene on a juvenile snake. I'll just kind of push and roll my thumb. And if they haven't figured out what I'm doing yet, sometimes the hemipene will pop out and I can identify the sex. But as soon as they figure out that I'm trying to do something back there, it's sort of like a lot of the girls I dated in high school. Then they were like, no, stop what you're doing. Are you guys sleeping on me now? Come on, dang. Anyway, all right. So sometimes you can do that, but most of the time the idea is you need to have anesthesia for this procedure. And actually, to be truthful with you, this is a procedure that can work quite effectively in the veterinary hospital. So we'll sedate, like this is a Varanus coming eye or whatever, and we sedated this animal, and under anesthesia, those muscles that are holding these hemipenal structures in place are relaxed because the animal can no longer fight against me. He's under general anesthesia, and when under general anesthesia, I can oftentimes pop these out. Now, the important thing to realize is that females, especially in the monitors and many of the Teliqua as well, and most lizards, actually the female has a structure, okay, called the hemiclitori or hemiclitoris, and that structure actually in many cases can look very similar to the hemipene. So not only do you need to manipulate it out, but you need to actually very gently roll it out, and you can see that all this elaborate the end of the hemipenis here where you see these ridges, and of course we all know from the interest that we have in taxonomy and stuff that even the structures of hemipenes have been used as ways to try to figure out if species are related, etc. So this would be, not rolling out this hemipenal structure. If I rolled it out and it had this very round, smooth tip, then you might figure you could potentially say this would be a female. It might actually be a female, and that's the hemiclitoral structure. But if you get this sort of structure at the end, of flowering, if you will, then again we can oftentimes identify these guys as males. So this is a technique that can work well. Unfortunately, even sedation usually isn't enough. So we usually have to almost have them under general anesthesia. Because if they're just sedated, we can't, again, override that musculature. But in general, it's a pretty safe procedure to do because, of course, we know a lot more about how to safely anesthetize lizards than we used to. We're very good at it now. One of the big questions is, when does this morphology actually occur? Like, does it take testosterone in the animal for a period of time before you get those changes in the end of that hemipenal structure? And again, that's a nice study for somebody to look at. We've started trying to look at that. But this can be an effective way to try to figure that out. What about radiology? It's something that people have looked at for years. We do know there's a study that was done or some information that was shared in a paper where varanids have ossification of the hemibaculae, which is the internal structure of the hemipene. And you can see here, this is a lace monitor, Varanus varius, and you can see here's those little mineralized structures that are within the hemibaculae, the internal portion of the hemipene. And so that can be an effective way. The problem, of course, that we have is it's not all species. It doesn't happen until they're older. So again, you can't really x-ray a young monitor, which is really when you want to know, and see these structures typically. Or if you don't see them, you certainly can't be sure. And then there's a large number of species, and many of these are ones that are fairly popular that it's not effective in. So can be helpful in some scenarios. So here's another technique that was recently developed by Stephen Mallet and some of his clients that work with blue-tongued skinks in Australia. He's a veterinarian in Australia, and he shared this information with me and actually published a small paper on it. And what he basically had decided to try was they basically took contrast medium, something called iohexol, which most veterinary hospitals, we have this because we use it to do contrast studies, and you inject that into the hemipenal sulcus or the hemiclitoral sulcus. And so here we are. This is an Egernia that we're doing. It's a syringe with some of the iohexol in it, and then we're using a 24 gauge catheter tip without the needle. And we're basically almost like we're trying to probe the lizard, okay, like you would a snake. And you gently introduce that catheter in, and then you inject the contrast medium into the hemipene or the hemiclitoral structure, all right? And then what we do is we take x-rays, and what we'll see, which I'll show you, is the male. And these are from Dr. Mallet. And so here on the bottom we have the male, okay? So remember that elaborate looking structure that we have? So this is what a male would look like. There's more structure to it, and you have this wavy, curly kind of a look. Females, either nothing was found, or a lot of times just a very straight line or very minimal change. So this was found to be quite effective in sexing a number of Teliqua, and they've done a number of species now, including rugosa as well. So this is a technique so it still involves, these animals typically do not have to be anesthetized for this, and it involves radiology, taking x-rays and getting your veterinarian involved, but it could be an effective way for you to try to sex some of your animals. So we took a group of Stokes eye. These are them as mature animals. This is them when they were a little bit younger, or maturing, if you will, and that's actually the pictures that I was showing you. One of the things we had to do is rig up a way to have them sit so that their little legs didn't block the area that we were trying to x-ray. So one of my technicians, we came up with this. We used a little roll of tape, and these guys were quite cooperative for this, so they kind of just sat there, and then this was the film. These are the x-rays that we took. So this was your typical male, and with the males, again, we got this pretty dramatic, elaborate looking pattern of this contrast medium hiding in here. The bummer with the Egernia, especially with the spiny guys, of course, is that all this keratinization of the tail, we couldn't see anything on what we call the VD view or the DV view. Okay, so really only the lateral view was useful. I don't have a picture of the females up here because the females, we basically didn't see anything. That we found that there was no residual iohexol that stayed in there for most. So, but we think now that they're maturing, we're going to go back and check them again and try to resex them and see how we did. But we think it was pretty effective for this group of animals. So again, another fairly non-invasive way for us to sex some of these animals. Ultrasound can also be an effective way to do it. It's obviously the nice thing about ultrasound is it's not invasive at all. The animals can be awake. Here's an adult lychee. Again, these guys aren't difficult to sex as much typically. And so we can look for these anechoic follicle. So basically, with ultrasound, you're sending sound waves into the animal, and it's bouncing back to your probe, and anything that has a liquid component to it is going to show up as dark, what we call anechoic, fluid-filled, like the bladder. Like when you put an ultrasound on a bladder, it's this big round circle with urine inside the animal. So what we look for with the females is with the immature follicles, they're basically like a little cluster of grapes inside the animal, tiny little circular structures that are typically fluid-filled when they're very young. And so this is kind of what you would see. The problem is that if you don't see the ovary, you can't say for sure. There's a possibility you could miss it. Perhaps the ovary isn't developed enough. Testicles are typically more difficult to see. They have a very similar echogenicity, we call it, to like the fat bodies that are in that area. So it's one of those difficult tests where if you see it, you can feel pretty sure, okay, yep, that's an ovary, okay, that's a female. If I don't see this, I can't quite be sure that it's either a male or maybe it's just a female that's still too immature. So it has its limitations, if you will. The other thing is that a lot of our species that we're interested in sexing, they have very heavily keratinized scales. And so those scales, like for instance, when you try to do ultrasounds on Carusia, the prehensile tail skink, there's so much ossification or density in keratin in the scales that you don't get good sound waves moving in. So it doesn't work as well for some of the species that we're the most interested in. Another technology that we've developed is celioscopy. Again, this is a lychee that we're doing. An adult animal, usually we can sex these guys without doing celioscopy, but we were doing another procedure in this female, so I wanted to use her as a way to show you. It's probably one of the most definitive methods because we're going to see the gonad, all right? Not only are we going to see it, but we can actually look at it and we can tell how active it is or whether it's a healthy gonad or not. But it is a more invasive procedure. It does require general anesthesia, and we are making an incision in the animal and going into those spaces. So this is what it looked like inside this girl. So right away we were able to see it's a female. This is an ovary with ovarian follicular activity here. We've got vitellogenesis going on. These are actually her intestines down here that look all crazy. And then this is cranial, on the very front of her. This would sort of be her chest area right at her neck. And you can see some ribs here, and this is actually the heart. If I had a video here, that you'd see the heart beating in here, and these are her lungs. And the lungs, when they're deflated, look quite bright red, but when they inflate with air, they expand out. And then this structure that you see, that's the heart here that we were just looking at. We're moving our back in the animal. You've got the ribs here. This is the liver, okay? And the liver of many reptiles typically has these pigmented cells on what we call the serosal surface. It's a very normal thing. It looks like disease, but it's actually not. It's very normal for most reptiles to have that. However, one of the things that's very interesting about this liver is it looks very fatty and yellow. You guys see that? Obviously you can see this is the edge of the liver. It looks sort of rounded and fatty. One of the things that happens with reptiles is when they're going through vitellogenesis and they're active reproductively, females will typically move fat into their liver as a very normal physiological thing, okay? So if you have a female that's follicular, if you will, typically that liver is going to have this color. So again, it's important for a veterinarian that's doing this would realize, hey, I don't probably need to biopsy that liver. That's probably a normal liver for a female Leachianus that is currently follicular. One thing that was happening with her, though, is we moved our way, but this is the oviduct coming down, and then this is her kidney right here, and it was abnormal looking here. And we did take a biopsy, but I didn't have a picture of that. She ended up having a nephritis, inflammation of her kidney, and then bacterial nephritis, which we treated successfully. But we can actually, this is actually a chameleon. This is I think it was a panther chameleon that weighed like 150 grams or something. We're still able to go in here and actually see a very unhealthy looking kidney here. What you're looking at, this is the testis. And then you have a kidney here, this is the fat pad, and this kidney, instead of being dark and mahogany, it's got all this irregularity to it. You can actually see urate crystals on it. And here's my biopsy instrument coming in, and we can take a nice little sectional biopsy from that and try to identify kidney disease or other things. So there's a lot of things that we can do with what we call celioscopy, not only sexing reptiles, but also diagnosing disease. So if you have animals that you're concerned about, another effective technique that we can use that's fairly non-invasive. One other technique that we've been looking at that's a little less invasive is something called cloacoscopy. Cloacoscopy is where we use that same rigid endoscope when we enter the cloaca. Now what we have to do is, the way an endoscope works is if you put the endoscope in and all the tissues are over the end of the endoscope, it's a rigid looking, sort of like maybe a little bit smaller than the size of a pencil. Well, if the tissues are laying on top of the end of the telescope, you can't see anything. So what you have to do is you have to move the tissues away from the scope in order to see. So what we use in the cloaca is we actually have an IV bag hooked up, and there's a line that runs in, and we introduce warm saline into the cloaca, okay? And when we do that, it expands the cloaca, stretches it out, and here's the opening into the rectum that we're looking at here. Okay, and then on the next slide, there's the rectum right there, okay? And then what we have here dorsally, there's the rectum there, that's the back end of the cloaca, as this is a female, and again, these are the kinds of things that I get excited about, is that who knew that Leachianus females had these crazy looking finger things around the opening of their oviducts, right? Nobody's ever described that before. So basically, a lot of reptiles, there's just an opening. These guys have these little finger things hanging down. I mean, it's the craziest thing. And the problem is when you do a prosection, if you do a necropsy and you just open these tissues up on a flat table, you probably miss this anatomy. You're not going to see how elaborate that is. So that's why this kind of technique where we're actually infusing the fluid and we're looking at the way this would look in the live animal, the morphology of it. Okay. So this is ventral. This is dorsal. So in the top portion of the cloaca are the openings into the oviducts. So this would also be an effective way to potentially sex a reptile. Part of the problem, again, is we don't know how easy is it to see those openings of the oviduct in what age of animal, you know? So again, these are all research projects that we're hoping to make progress on. So that's lizards, probably one of our most challenging. So let's talk about sexual dimorphism in our chelonia. These are all things you guys are familiar with. You know, we've got in our aquatics, you know, a lot of these guys, the males have the longer nails for flirting with the girls, et cetera. And then we've got the lengths of our tail, females with a shorter tail and the male with a longer one because the phallus is in these areas. And then concavity of the male compared to non-concavity of the female. Box turtles, you know, the classic, the males typically, not always, but may have these brighter colored eyes. And then again, you can definitely see the changes in the plastron here with that concavity in the male compared to the female. So we've got some of those characteristics. Again, typically things we're seeing in adult animals, and so not something we see. And that's because those characteristics are developed with sex hormones in the body, and those changes occur then. Can we use ultrasound? Sure we can. We have to use a lot of gel, and we have to have an ultrasound probe that will hopefully fit in this little space here in front of the rear limb. This is what follicles, what we call vitellogenic follicles would look like in, say, a tortoise. This is a more mature animal. The problem is this little guy right here, let's say you just hatched out a whole bunch of yellow-footed tortoises and you want to sell them, and people want to know what the sex of it is. Well, you can't get the ultrasound on that guy, he's too small, one, but even if you could, the ovaries probably aren't developed enough for us to see those little round black circles. So it hasn't been very effective for young baby tortoises or for juvenile tortoises. So this can work for some tortoise species that maybe the adults don't have a whole lot of sexual dimorphism, but again, not for the wee guys. So this was a really cool paper that we published with my colleague Stephen Divers at the University of Georgia, and we basically had a conservation group that presented us with 50 of the Chiora flavor marginata, with the idea being that, hey, we have 50 of these babies, and we want to send them out to different zoos and groups to work with them so we can try to help with conservation. Well, the problem is we don't know the sex of them, right? So when we're sending out groups of animals to the zoos, and they might spend all this time raising them up and not have proper sex ratios, et cetera, right? So we felt it was very important to see if there was a way that we could effectively sex them. And so what we were able to do, these were animals weighed on average about 10 grams. So you have a little 10-gram animal. We were able to use anesthesia, making a very small incision, go in with our endoscope. Instead of air, which a lot of times when we do celioscopy, we use air to move the tissues away from the endoscope. But in these little guys, we did like we do with the cloaca. We actually introduced saline, warm saline, into their little coelom. And sure enough, the females had this beautiful little ovary here. Isn't that gorgeous? It's almost like you guys talking about locality data and stuff. So I think that's just beautiful. I mean, I would hang that up in my living room. And then here's the male down here. They're very different. So very, very different. The saddest thing of all was we had like 48 males and 2 females. So as much of a bummer as that was, though, think of the value of that project, because those people could have they sent those out and spent years raising those babies up, you know, to only realize they had all males. So this is the kind of thing that we can do as veterinarians. So a number of us now, I have people that will bring a bunch of baby radiated tortoises in, and we'll figure out a fair price for me to go through and sex all those babies and do that safely, things of that nature. Those are the kinds of things that some veterinarians that are out there would be able to offer to you guys, in figuring out ways to help you to be able to say, hey, I've got a 1.2 group I can sell to you because they were sexed endoscopically by Dr. Divers or Dr. Stahl or whoever may be able to offer that to you. And then, let's see if I can get this to work. Hopefully it will work. Press the button. Yeah. So here's just doing an endoscopy on an adult. This is an adult tortoise that we were sexing. And again, this is the adrenal gland. Here's the testis here, and then the epididymis that you can see here. So obviously, not only can we see that testicle, but we can also identify if it looks healthy, is it mature. We can actually take a biopsy if you're having issues with, let's say you're not producing, you've got a very rare group of tortoises and you're not having good luck. We can actually endoscopically evaluate the testicle, take a biopsy, get cultures, whatever, to try to help you guys figure out why we're not producing baby tortoises, etc. And then cloacoscopy. Here we go again. So we're talking about turtles and tortoises. A couple of our colleagues in Italy came up with this idea where we basically do the cloacoscopy through the bladder. And here we are. We're now in the bladder. This is an aquatic turtle, and this turtle is upside down. You guys see some structures that you think you might recognize in this? See how thin-walled the bladder is. So we've expanded it with fluid, like we talked about. And watch as we're backing out. If you look over here to the right, you're going to see something. I want you to tell me what sex you think this baby turtle might be. Anybody see anything? Yeah, that's a urate floating around. Isn't that fun? Okay. But did you see the ovary? You could see it quite readily. Okay. So we didn't have to make an incision in the animal. We were able to actually go in through the cloaca with some warm state. Now these animals do have to be sedated usually for this. By the way, look at the accessory bladders when we come out. This is an aquatic turtle, and there's these pretty dramatic, what we call accessory bladders. They're going to be on the right and the left as we come out. See one over here and one over here, and then that was the bladder there that the urethra we went down. So these are all things that we can do. We can also do a lot of things with this technology for other things as well. Looking at, let's say we have a reptile that's passing blood out of its cloaca. Well, we can do procedures like this to go in and look for disease or issues, etc. And then this is probably a little over the top. Sure, we can do CT scans too. This is a mature red-footed tortoise that you can see these follicles in here on her, but it's just so cool to put these 3D renditions. But that's a little pricey for trying to sex a tortoise, but we invested in a CT scan in our practice, and CT technology is wonderful for one, and it is slowly coming down. It cost me $250,000 to put that in my clinic, and I just added that onto the $1.5 million that I already owe, but it does fantastic stuff, and I can use it for a lot of reptile projects I'm interested in doing. So the CT is one of the nice things about this CT is it takes about 960 images in a circle around the animal, and the amount of radiation is no different than that of just a normal X-ray. So it's fairly safe for the animals, and we get so much more. You can imagine how much more information we get with 960 images to look at as compared to just 2 when we take the 2 views from a normal X-ray. So pretty cool stuff. But here's probably where the future might be. Molecular DNA, hopefully at some point we will have like a blood test that we can sex a lot of our animals with. There is one that's been developed for the Komodo dragon that is available through some research groups. And then unfortunately what happened is a number of years ago through the bird community, there was a sexing, there's basically blood tests that are available for most parrots. We can draw a drop of blood and send it off and they can do a DNA sexing for us. Well, they developed one for the green iguana because they thought this will be great, and then we're like, nobody cared about the sex of their green iguana, so they didn't sell it. So then they just completely backed out, and then we called them and said, hey, how about like bearded dragons and leopard? And they were like, no, the technology's too expensive. We're not interested. The green iguana thing didn't go. So anyway, but hopefully somebody will jump on board, and imagine having a sexing test for a bearded dragon. I mean, people would go nuts over that. So hopefully that'll happen. And then maybe looking at hormones in the blood and the feces, like it's done in a lot of research now, where people collect feces and look at hormone data. The problem with it again is that we're probably not going to see those hormonal changes in the younger animals.
adults. Okay, so again, this maybe won't work as well for the juveniles that we're trying to figure out.
All right, we're going to stop here and pick up next week for part 2 of this talk for 3 reasons. A, you may have noticed the audio is starting to get a little wacky at the end there, so we got that fixed in part 2. B, Scott is about to dive into the next section, which is how to determine the fecundity of a female, or how to tell if she's gravid, and I'll assume he'll cover many other species as he did in part 1. And 3, that was a little bit long anyway, so I feel cutting it in half is a little, give you time to soak up the information from part 1 and then move on to part 2 next week. Until then, you've been watching Triple B TV. Y'all take care.